Alright, let's start A5. Number 9, they're asking you to determine if the relation is a function. So for number 9, it is not, because you have one input value going out to 3 different output values. So I just did the lines to show it, to show the connection, just because it's a lot of writing. So this is just not a function. And when it says explain your reasoning, you would say because one input value is paired up with 3 output values. So the National Football Conference is being paired with the Giants, the Saints, and the Seahawks, while the American Football Conference is being paired up with the Patriots, Ravens, and Steelers. Number 12, if you notice the input values, I have 2 zeros and 2 ones that are paired up with different numbers. So 0 is paired up with -4, and then 0 is paired up with 0. 1 is paired up with -2, and then it's paired up with +2. So this is not a function. Okay, because again, you have an input value paired up with 2 output values. Okay, for part A, they took numbers from set A and paired them up with set B, and it follows a function rule where none of the x's are repeating. So yes, A is a function. B, again, just going across this list of ordered pairs, you have 1, the input 1 being paired up with -2 and 1. So B is not a function. The reason why: 1 is paired up with -2, and then later on 1 is paired up with 1. So you have one input value paired up with 2 output values, and that does not constitute a function. And then C, at first glance it does look like a function, right? Because if you look across, none of the x's repeat. The problem is it's asking you whether this represents a function from A to B, and C is not that. C is actually from B to A. So you would say no to this one, because this is not what we see. And the question is specific about asking about the pairing A to B. Okay, so that's why this is not a function. Okay, so for number 18, they want you to read the graph. So B of 2009, so we're looking at the black points, that's the name brand graph, and we're going to look at 2009, which is right here. So we're going to go straight up, and it's the point, let's see, 2009, it'd be this point right here, okay, that I circled. So that one is just past 150. It's not centered on 150, so I would say it was anywhere between 151 and 152. Okay? Again, we're just approximating. G of 2006, we're looking at the blue dots. Okay, that's the generic graph, the graph with the generic data. And we're going to look at 2006, which is this one right here. Okay? And reading across, it's past 25 definitely. So I would say anywhere between 30, 31, around there would be good estimates for this problem. So $30 to $31. 21, they're asking to determine whether the equation is a function, whether it represents a function y as a function of x. So this one is yes, because for every input that you put in here, you get one output. All right, for 24, I'm going to isolate the y, because we want to know if y, we want to see if y is a function in terms of x, right? So we need y by itself. So I'm going to move the y to the left side, so that's y plus x equals 5. I'm going to move the x to the other side, like that. So this is what we have. And for every input that I put in there, I'm only going to get one output. So yes, this is a function. Okay, number 27 is an absolute value equation. And for every x that I put in, for every single x that I put in, I get one y back, or one y as an output. So again, this is a function. Number 30 is y equals 8. Remember, this is a horizontal line. So horizontal lines are functions. They pass the vertical line test. So this one, yes, is a function. Because again, remember, it's a horizontal line. Here's 8. It goes across this way. For 33, we are evaluating the functions at different input values. So h of 2, we're replacing the t's with 2's. So this is 2 squared minus 2 times 2. So then I get 4 minus, whoops, sorry about that, 4 minus 4. So we get 0. That's our answer. H of 1.5, same thing, 1.5 replaces the t's. So 1.5. 1.5 squared is 2.25 minus 3. So you get negative 0.75. And then h of x minus 4, the t's become x minus 4's. So this is, remember, this is x minus 4 times x minus 4. So you get x squared minus 8x plus 16 minus 2x, oops, 2x, I'm distributing the negative 2 over here. So then that's plus 8. Common terms or like terms, I get x squared is by itself. Negative 8 and negative 2 is negative 10x. And then 16 and 8 is positive 24. Alright, for number 36, I replace all the x's in the equation with negative 4. There's only one x, so it's going to be square root of negative 4 plus 8, oops, plus 2, sorry about that, fix it, plus 2. So that's 8 minus 4, that's 4, square root of 4 is 2, and the answer is 4. For the next one, 8 plus 8 plus 2. So 8 plus 8 is 16. The square root of 16 is 4. So that gives me a 6. And then the next one, x minus 8 plus 8 plus 2. So right here the 8's cancel. So I'm left with the square root of x and then the plus 2 on the outside. Okay, so f of 9. Replace the x's with 9's. So absolute value of 9 is 9. So 9 over 9 is 1. The next problem, absolute value of negative 9 over negative 9. So the numerator is 9, the denominator is negative 9, and we get negative 1. For C, replace the x's with t's. So like this. Now, I can't just go ahead and I know that some of you may want to reduce the t's and cancel and get 1, but the thing, look at examples A and B. When it's positive, we get a positive 1. When it's negative, we get a negative 1. So we don't know if t is positive or negative, so we can't really simplify it any more than what we have there. So the final answer is actually that right here. We can't simplify it anymore. That's as simplified as we can get it because we don't know if t is positive or t is negative. Alright, 42. I've got 2x plus 5 and 2 minus x as pieces of the piecewise function. And so I know if I need to solve f of negative 2, I need to determine is negative 2 in this domain or is it in this domain. So I know that negative 2 is less than 0, so it's going to be here. So what that tells me is I have to use this piece of the function. Okay? So 2 times negative 2 plus 5 becomes negative 4 plus 5, which is 1. Okay? Same thing for 0. 0, I see 2 zeros right here, right? But this one includes a 0, this one does not. So the one I'm going to use is this one, right? It's here. So I'm going to use this one again to evaluate the 2x plus 5. So 2 times 0 plus 5 is 0 plus 5, which is 5. And then the last one, f of 1, well, f1 is greater than 0, so it would go here in this domain. So that means I'm going to use this piece of the function right here for part C. So it's going to be 2 minus 1, and so the answer is 1. So 45 is another piecewise function. First we need to evaluate f of negative 2. So negative 2 is less than 0, so it's in this domain right here. So that means we're going to use, this piece of the function, x plus 2. So replace the x with a negative 2, so negative 2 plus 2, which gives me 0. Okay. Next one is 0, f of 0. So 0 is here in this part of the domain because this includes a 0, so that means we're going to use this piece of the function. Well, all that tells you, the 4, is that no matter what x value you input in for this piece, for the middle piece, your answer is always going to be 4. Okay, that's what it is. It keeps moving, sorry. So the answer is 4. And then for f of 2, we're going to use this piece right here, because the domain 2 is here, because it says x is greater than or equal to 2. So the piece of the function we're going to use is this one, x squared plus 1. So we put 2 squared plus 1, so that's 4 plus 1, which is 5. For 48, they want you to use that function to evaluate the function at these x values. Okay, those all came from set A, which is comprised of these 5 values. So basically all you're doing is replacing the x with each of those and evaluating. So negative 2 squared minus 3. So negative 2 squared minus 3. So that's going to give you, let me copy the x coordinate, 4 minus 3, which is 1. And then negative 1 squared minus 3. So that's going to give you 1. Negative 1 squared is 1. 1 minus 3 is negative 2. And then 0 squared minus 3. So that's going to give me 0. 0 minus 3 is negative 3. And then 1 squared minus 3. So 1 is associated with negative 2. And then 2 squared minus 3, which gives me 4 minus 3, which is 1. Okay, for this last problem is very similar to the previous one, where we're replacing the variable with each of these 5 values and then just figuring out what you get. So for the first one, negative 5, I get 1/2, negative 5 plus 3. So this gives me negative 2, but absolute value of negative 2 is 2, so 1/2 times 2 is 1. And then we do the next one, 1/2, absolute value of negative 4 plus 3. So I get 1/2 absolute value of negative 1, which is 1. So 1 times 1/2 is 1/2. And then the next one, 1/2 absolute value of negative 3 plus 3. So I get 0. So any number times 0 is 0. And then 1/2 absolute value of negative 2 plus 3 is 1. So 1/2 times 1 is 1/2. And then the last one, 1/2 absolute value of negative 1 plus 3, you get 2. So 1/2 times 2 is 1. And that's it.